Hi everyone, in this video I'm going to be doing an overview of inferential statistics. Inferential statistics is a way to learn from data and make conclusions. It is commonly used in data science to learn patterns and underlying processes in the data, and we use what we learned to make predictions. So let's get started. I'm going to go over some of the jargon and some of the terminology that often comes up in statistics that's very relevant to predictive modeling. So the first idea we're going to talk about is the concept of a population. The population is the set of all observations that we are interested in studying. The population is what we want to learn about. So for example, suppose we want to know the average salary of a data scientist. So we want to know the average salary of a data scientist. And in this case, for this research question, the population of interest would be all data scientists in the world. So let me just write that down. So the population could be all data scientists in the world. Okay, so let me actually draw this as well. So in red, I'm going to draw the population. So suppose here we have a population, and in the example we're looking at is this is the population of all data scientists. Next, we have something called a parameter. And what a parameter is a number which describes some characteristic about the population. So recall the initial research question I had. What is the average salary of a data scientist? So in that case, the parameter is the mean parameter, which is the average salary of a data scientist. And something I should say about parameters are usually denoted by Greek letters. So for the mean, very commonly mu denotes the mean. So in this case, mu is going to be the average salary of data scientist. So suppose we had the salaries of all data scientists in the world. Then we could simply compute the average and determine this parameter mu. So the population is what we would need if we wanted to compute the exact value for mu, the average salary of a data scientist. But the problem is that populations in social sciences tend to be very, very large. So you can imagine that there's a lot of data scientists out there, and we're not going to be able to connect information for all their salaries. So what we do in statistics instead is we make inferences on the population by using a subset of the population, by using a sample. So a sample is a subset of the population. So let me actually describe that in this figure. So in red, we have the population of data scientists, but we're not going to be able to go talk to every data scientist in the world. But what we might be able to do is talk to, let's say, 100 data scientists. So within this population, we're going to take a sample. So in blue, I've drawn a subset of the population, and this is a sample. So a sample is a subset of the population. For example, a sample could be the sample of 100 salaries of data scientists. So x1, x2, all the way up till x100. If our sample size is n equals 100. And basically what x1 is the salary of the first data scientist we survey. x2 is the salary of the second data scientist we survey, and so on. So xi is the salary of ith data scientist. Okay, so that's what the sample is. It's just a subset of the population. Now, once we have our sample, we want to use that sample to make inference about the population. So this is where a statistic comes into play. A statistic is a number that describes some characteristic about the sample. For example, the statistic could be the maximum salary, or it could be the minimum salary, or it could be the median salary. So those are all examples of statistics. A statistic more generally, is just a function of the sample. So statistic would just be a function of the sample here, x1, x2, all the way up till x100. So essentially what this is saying is you take the sample, in our case this is a salary of 100 data scientists, you summarize the sample using some function, and this function is a statistic. And the example of a statistic which might be relevant for us would be the mean, x bar, so the average mean, which would be just taking the salaries of all the data scientists from 1 to 100 and dividing by 100. The average salary of the data scientist in our sample. So from the sample, we can get x bar. So this is the entire idea. We have some population. The population is very large, and we're interested in knowing some characteristic about the population. We're interested in knowing the parameter. Now, if we had the entire population, we could determine exactly what the parameter is. But in reality, the populations we tend to work with are very large in data science. So what we do is we collect a sample, and we use a sample statistic to make inference about the population. Okay, so next what we're going to talk about is we're going to talk about estimating parameters. So far what we have discussed is we have a population. So I'm going to draw it again. So we have this population in red, and this population is associated with some parameter. For example, mu, the average salary of a data scientist, which we considered in the last slide. So the problem with determining mu is that the population is generally unobserved. Okay, it's too large to observe, and because the population is too large and we don't have data on the entire population, we cannot compute the exact value for our parameter of interest. So what we're going to do is we're going to use a statistic to make inference about this parameter. So essentially the idea there is that we're going to take a sample from this population, and from this finite sample we're going to compute a statistic. So the statistic would just be a function of the data, f of x1 all the way up till f of x, all the way up till xn, where n is the sample points we have. Okay, so formally, a statistic that is used to make inference about the population parameter is known as the estimator. Okay, so the estimator is just a statistic that's used to make inference about the population parameter. That means this estimator is a function of the data that is informative about the population parameter. So in our case, a relevant estimator would be x bar. X bar is the average of sample, and this would allow us to make inference about the population parameter mu. Okay, so this would be informative about mu, but we can also have many other statistics. So we could also have the median statistic. So we could have the median of the sample, x1 all the way up till xn, and this median statistic would be informative about some other parameter. So in this case, it could be informative about alpha, which is the median of the population. So the key point here is that the population is unobserved, so we cannot determine these parameters, which represent some characteristic about the population. So what we do in statistics is we go collect a sample, which is a subset of the population, and then use the estimator, which is a statistic that is informative about the population parameter. Next, we have a very similar concept, which is known as the estimate. And what the estimate is essentially the output of the estimator. So recall that an estimator is the function of the data. It takes in the sample and it outputs some number. The number that's outputted by the estimator is the estimate. So let's look over an example. So suppose we have some data points. We have data on three people's salary, three data scientists' salary. Suppose, for example, the salaries are 10,000, 20,000, and the last data scientist has a salary of 30,000. Okay, now I can use this data to compute an estimate. So what I can do is, if I want to compute the average estimate, so if I want to compute X bar, then I can essentially take 10,000 plus 20,000 plus 30,000 and divide this by 3. And this would be 30,000 plus 30,000, 60,000 divided by 3. I would get the estimate of 20,000. Okay, so this 20,000 is an estimate. The function, which is the average, is the estimator. Now I could also have the median estimate. So I could just take the median of 10,000, 20,000, and 30,000. And in this case, the median would simply be 20,000. Okay, so in this case, it worked out that the average estimate and the median estimate are the same. It doesn't have to be like that. But the main key point is, once we plug in the data into the estimator, the output we get, this is called the estimate. Okay, so far we have talked about population parameters, a characteristic about the population. We have talked about estimators, which is a statistic, a function of the data that we use to make inference on the population parameter, and then an estimate. An estimate is simply the output of an estimator once you plug in the sample. I hope you enjoyed the video and learned about inferential statistics. We will be considering applications of this to data science in future videos.